4. And this time we go to a bracket 0, because I equals to 0 in this case. A bracket 0 has a value of 2. We use 2 to update I. So now I has a value of 2. We go back to line 5. We compare I to k, check whether they are the same, and this time they are indeed the same. And once the exit condition of a post-checking loop is true, we get out of the loop, and that concludes the trace. Are there any questions about this particular algorithm and the trace associated with it? No questions? I'm hoping that you guys realize that I have not used any concept other than the concepts that we have already gone through in the class. It's just combining those concepts maybe in slightly newer ways that we may not have seen before. Yep.
You have an array where you update the values in the indexes.
Say again?
The values of the indexes of an array, like you a bracket I, or you have an array that changes the values of those, like there are known at the beginning and the
I'm not exactly sure what you're asking, but let's take a look at the next question and see whether that answers your question. Yep.
Like for that one that you show, it doesn't have anything to do with A at all.
It does not change the values of the elements in array A.
So
Because A bracket something never appeared on the left-hand side of an assignment statement.
oh, that's
this is a post-checking loop. That's why we're not in the array, right? Or
Say again?
is this a post-checking loop?
Yes.
Loop?
Repeat until is a post-checking loop. Yes. All right. So I think that answers your question. This one starts with everything is unknown, okay, which is. And here's the code. I did not properly format the code itself, but that's okay. There we go. Now this one is kind of interesting because the first line initializes one of the elements in the array. The second line initializes I, which is also used to indicate which element in the array am I trying to access. Line 3 is starting to look a little bit weird because we usually say I is less than bar A bar, and this time we say I is less than bar A bar minus 1. Okay? Now, don't think that I might have made a mistake or a typo. During the test, just go ahead and trace it and see what happens. If you suspect that I might have made a mistake, raise your hand and ask me, okay, Tech, did you make a mistake here? Before you conclude that it was a mistake and decided, oh, maybe technical really meant without a minus 1. Line 4 is probably the big question, okay? Do we know how to do with line 4? Yeah, even though on the same line I use I for different purposes. What is I, by the way? It's an integer variable, right? So I by itself is nothing more than an integer. It can have a value of 0, 1, 2, and so on and so forth. But it can also be used as an index inside the square bracket notation. So there's nothing preventing me from doing something like this, using I both as the index inside the indexing operator, the square brackets, as well as using just the value of the variable I at the same time in the same expression. There's no rule saying that that cannot be done. And it computes to one particular value. I use it to update the value of another element in the array, which is on the left-hand side, and that's it. Okay, so it does not have anything that is really new that we have not talked about. It is just combining things in a special way that is kind of unique to this question. So we'll go ahead and take a look at the trace and find out what it is actually going to do. Some of you, the math inclined, can probably kind of tell what it is doing. But we'll go ahead and trace it. After, maybe by the time we work out column F, you guys will realize exactly what it is doing. Okay, the precondition is nothing is known because everything is going to be initialized in the algorithm itself. Yes?
You don't have a K in your trace either?
I do not need a K. There are no variable k's in this case.
Line 6 says until I equals k.
Okay, I forgot to change that line. You are good. I made a mistake. I made a big poo-poo here.
That looks like an error on copy paste.
Yep. This is why copy, paste, and modify is evil. Yet another demonstration. If I had typed this program from scratch, I would not have made this mistake.
Is that what happened with the first homework assignment when you took out the update and said it was you sent out an email and you corrected it?
Right. No, that was a different thing. That was not the result of copy and paste. But this one definitely is. Okay, it should have been an and while, because otherwise you have the beginning of a pre-checking loop but the ending of a post-checking loop, and that certainly is something new that we have not talked about, and I don't even know what that means. Okay, good catch, very good. Yep, I am embarrassed, but I'm glad that you guys can spot the problems before we even trace it. So you guys can just glance at the algorithm and say, oh, something is not right here. That is good. Okay, line 1. Okay, A bracket 0 gets a value of 0. Column D gets a value of 0. Line 2, I gets a value of 0. Okay, well, variable I gets a value of 0. Not a problem. We go to line 3. This time we have to trace line 3 because it is a pre-checking loop, and the first line of a pre-checking loop is significant. I is less than bar A bar minus 1. Well, let's check out what is bar A bar. Bar A bar is 4. 4 minus 1 is 3. I is 0. 0 is less than 3 is true. We go in and we go to line 4. Line 4 is the big question. What is it going to do? Well, I is 0 at this point. When you look at the right-hand side of line 4, A bracket I refers to A bracket 0, which also has a value of 0. I itself has a value of 0, so this becomes 0 plus 0 plus 0 plus 1. Okay, so the entire thing adds up to just 1. We use this value to update A bracket I minus 1 close bracket. I is 0, I plus 1 is 1. In other words, we are copying the value of 1 to overwrite A bracket 1. A bracket 1, or column E, is now having a value of 1. Are there any questions at this point? Because the next 3 iterations will basically be doing about the same thing. I should say the next 2 iterations, there are 2 more. Yeah.
If I and I are the same value, why did you write plus I plus I instead of just plus 2I?
No particular reason.
Okay.
Actually, there is a reason. I'll explain that later.
Okay.
Yep. The reason is out of the scope of this class, but I will mention it anyway. Okay, so we go to line 5. Line 5 does a very usual thing, adding 1 to I. I goes from 0 to 1. We go back to the beginning of the loop. I is less than bar A bar minus 1 is once again true, because we already know bar A bar minus 1 is 3. 1 is less than 3 is true. Then we go to line 4. If you can deal with line 4 in the prior iteration, you can deal with line 4 this time. You just have to be careful of what I is, because then you have to make sure your calculation is correct. Okay, I is 1 at this point. A bracket I refers to A bracket 1, which has a value of 1. So we have 1 here. I itself is also 1. We have 1 plus 1 plus 1, and then plus the literal constant of 1. That's 4. And we use 4 to update A bracket I plus 1 close bracket. Since I is 1, I plus 1 is 2, so we're updating A bracket 2 with a value of 4. Can you guys guess what the algorithm is doing? It's calculating the squares. A bracket I has the value of I squared. Okay, but it does not use multiplication. There's no multiplication used anywhere within this code. Then we go to line 5. I gets incremented again from 1 to 2. Then we go back to line 3. I has a value of 2. 2 is less than bar A bar, which is 3, is still true. This is our last iteration. We go to line 4 again, and since we have already done it so many times, this time we should know what to do. I has a value of 2. A bracket 2 has a value of 4. So the first part of this right-hand side is specifying 4. But I itself has a value of 2. So this expression is really saying 4 plus 2 plus 2 plus 1, which is 9. Okay? So we now update A bracket 3 with a value of 9 because we specify I plus 1 inside the square brackets on the left-hand side. I is 2, 2 plus 1 is 3, and that's why we're updating A bracket 3 or column G. Then we go to line 5. Line 5 adds 1 to I goes from 2 to 3. Then we go back to the beginning of the loop. I is now 3. 3 is less than bar A bar, which is also 3, is finally false, and we are done. Okay. So how did we calculate the squares without using I times I in this program? What did I use? What did I utilize to calculate the square, but without using multiplication at all? I use, what is that?
X squared.
That is x squared plus 2x plus 1, right? If you change x to I, sort of, okay, it becomes kind of like that. And then if you change your I minus 1, whatever squared to A bracket I or A bracket whatever that is, then you have A bracket I plus 1 equals to A bracket I plus 2I plus 1. But I also, I don't want to use multiplication at all, so 2I becomes just I plus I. Okay? But the next question is, why do we have to go through this to calculate, squares? Why not just use multiplication, or better yet, the square function in most, programming languages? Well, multiplication is fast when you have a Pentium type processor, but when you have a processor that will cost you $1, okay, it does not have any hardware multiplication instructions. Okay, that processor natively can only perform comparisons, additions, and subtractions. Okay, which means if you need to perform multiplications like this, it will take a lot more time than just doing 2 additions, than turning it into one single addition. And that's why this is actually a technique of optimization. If you know that you have to calculate the square of a number, but you always start with the square of a number that is either one larger or one less than the number that you want to square, then you can always use a trick like this and convert multiplication all the way down to just additions. You might be wondering, but how much time are we saving? I mean, is it even worth doing? And my answer is yes, it is worth doing, because in a micro mouse application, a robotic application, if my students used multiplication, the program would not work at all because it is taking too much time. But when they use an optimization technique like this, then the program actually works a whole lot faster than without the optimization. Okay. Any questions about this code? It also serves as a good question for this class. Yep.
Is there going to be questions around the beginning and end of the array? B and E?
You mean binary search?
Yeah.
There'll be, there will be at least one question, related to binary search.